Greetings, gentlemen, and welcome to the Smart Video Lab. It's Mr. Gordon here with a couple problems off the test review. So number 22, I'm working on number 22, is a review question of linear functions. It says the graph below indicates the value of a small used car as a function of how old the car is. Part A, estimate the slope and y-intercept of the line. Explain how you made each estimate. So I already know if I'm going to find the slope, my explanation, I need to do rise over run. So I need to pick two nice points on the graph. How about this first one? And then this one right here. I need to figure out the rise over the run. So that's a decrease from 11,000 to 6,000, a decrease of 5,000, so negative 5,000. So my rise is negative 5,000. My run, that's a horizontal increase of 4 years based on the scale down here, going by ones. So my run is 4. Negative 5,000 divided by 4 is negative 1250. So my slope is negative 1250. Now the y-intercept is just this point right here where the graph hits the y-axis, and that's 11,000. Or if you want to be super precise, 0, 11,000. So the explanation is where the line hits the y-axis. Now, I need to write a function rule. So remember, function rules for linear functions are of the form y equals mx plus b, where m is the slope and b is the y-intercept. So my slope is negative 1250, so it's y equals negative 1250x plus 11,000. Now we get to a very important question in part C. That's a terrible 0. Let me fix that. In part C, explain the meaning of the slope and y-intercept in terms of the value of the car and the age. So let's think rise over run. Negative 1250 over 1. That's rise, the y-axis, which is measuring the value of the car in dollars. So that's negative 1250 dollars for every one. The x-axis is measuring years, every 1 year. So what that means in a sentence is the value of the car decreases by $1,250 each year. Now, the y-intercept of 11,000 means that the initial value of the car was $11,000. So there we have it, problem 22. The equation y equals negative 1250x plus 11,000. That means the value of the car decreases by $1,250 each year, and its initial value is $11,000. Now, going to number 8 on your test review. So number 8 on your test review, it's the instructions at the top of this section are to simplify each polynomial expression. So whenever I have two parentheses next to each other, that means multiply. So I need to multiply these two binomials. So I need to use the distributive property twice. 2x times 3x, 6x squared. 2x times 8 is 16x. That's once. Distribute this. Negative 4 times 3x is negative 12x. Negative 4 times 8 is negative 32. So I multiply by distributive property. Now I can combine like terms to add. 6x squared has no like terms, so it comes down 6x squared. 16x minus 12x becomes plus 4x, and then minus 32. And that would be my final answer for number 8. Now, if you look on your test review, there's a section that has no number. I did that on purpose. So it says factor each polynomial expression. So you can think of this as the factoring section of the test review. It's got just letters, no numbers. So in the factoring section, if you turn there on the bottom of page 1 and into page 2 of your test review, we're going to do those problems. So remember the steps for factoring. Let me add a sheet, steps for factoring. So what do you need to do first? Always look for a GCF. Second, look for a pattern. The only pattern we know is a difference of squares, which happens only for binomials. And then third, look for and apply the X factor as a graphic organizer, which is only for trinomials. So if I look here at part A, step 1, is there a GCF? Absolutely there is. I can factor out 2, and then this one has 3 x's, this one has 2 x's, and this one has 1. So the most I can take out fairly is just 1x. So if I do 6x cubed divided by 2x, I'm left with 3x squared, negative 4x squared divided by 2x minus 2x, 12x divided by 2 plus 6. So I factor out the GCF, and that's what that looks like. Part B, look for a GCF. There is none. So maybe it's a difference of squares. This is a binomial, so it could be a difference of squares. It is, in fact, the square root of 144 is 12, so it's x minus 12, x plus 12. Now part C, first look for a GCF. Is there a GCF? Certainly it is 2. So if I factor out 2, what's left inside is just 5 plus 25t minus 8t squared. So that's part C. Part D, look for GCF first. There's a GCF of 3, so when I factor that out, I'm left with x squared minus 16. Now, this is a difference of squares. So it becomes 3 times x minus 4 times x plus 4, because the square root of 16 is 4. Part E, I look for a GCF. There is none, but it looks like a difference of squares. This is 4x squared minus 5 squared, because 4x times 4x is 16x squared. 5 times 5 is 25. So that factors as 4x minus 5 times 4x plus 5. Part F, no GCF. It's not a difference of squares because it's not a binomial. So I need to try the x factor. So it's going to be x and x. Things that multiply to 21 that might add to give me 10. How about 7 and 3? So on the diagonals, check. On this diagonal, I get 7 times x is 7x, plus on this diagonal, 3x. That's 10x, which works to give me the middle term that I wanted. So that factors as x plus 7 times x plus 3. Now, part G, x and x multiplies to give me x squared. Negative 9 and negative 5 multiply to give me positive 45, but might potentially add to give me negative 14, which is the middle term. So let's see. In that diagonal, I get negative 9x plus. On this diagonal, I get negative 5x. Negative 9x plus negative 5x is negative 14x, which is in fact what I wanted in the middle term. So we're good. So that means that this expression factors as x minus 9 times x minus 5. Now notice I don't need to go any further because my instructions say to factor. Factor means write as a product, which I have done here. Because remember, when you have 2 parentheses next to each other, multiplication is implied. Now, H and I, you have the answers to. Same process, X factor. You can check those yourself. Couple more review questions. Number 23, it says the number of bats in a bat colony grows by a consistent percentage every year. The number of bats n after any number of months t is modeled by the rule n of t equals 400 times 1.3 to the t. So remember exponential functions, which this is a times b to the x. Now, it says what is the starting population? A represents the starting value, and our A here in this case is 400. So the starting bat population is 400 bats. Now B represents the growth factor. So B growth factor in cases of growth. This is a case of growth because this is bigger than 1. So 1.3 is the growth factor, but that's not the question. The question says by what percentage is the bat population growing? So 1.3 comes from 1 plus 0.30. Now 0.30, if I write that as a percent, is 30%. So the bat population is growing by 30% each year. Now question C is going to require a calculator. It says when will the number of the bats in the colony reach 200,000? So I need to go to my calculator, home screen, new document, save changes, no, add graphs. I need to plot the equation, 400 times 1.3 to the x power. And I don't need to see anything. I can just press Control T to look at the table. And I'm looking for when the population gets up to 200,000. So there it is at 128,000. So right there we can see it's somewhere in between 23 and 24, closer to 24. So I'll just round. So approximately 24 months, which if you cared, is 2 years. So in 2 years, that bat population, if it's grown by 30% each year, will be at 200,000. It's a lot of bats. 24, similar, except this time it's decay. The value of a pinball machine decreases, keyword, each year according to the rule V of t equals 700 times 0.88 t, where V represents to the t power, where V represents the value in dollars and t represents the time passed in years. What's the value of the pinball machine when it was brand new? That comes from our A value, $700. By what percentage is the value of the pinball machine decreasing each year? Well, 0.88, if something keeps 0.88 or 88% of its value, how much does it lose? If it keeps 88%, it loses 100 minus that, which is 12%. So it's decreasing by 12% each year. What will be the value of the pinball machine in 30 years? I can just type 700 times 0.88 to the 30th power in my calculator and see what I get. So I do that, and I get 15.12. So that's 15.12, $15.12. That'll be the worth of that pinball machine in 30 years. Not a lot. Last up, we've got some more quadratic equations that you guys were asked to solve by factoring. There's another video that has these questions in it. And 15, 16, and 17, you guys also have the answers to. So I believe that's all I wanted to mention for this video. Have a wonderful, wonderful day.